Buongiorno baddies, welcome back to another video. Today's first question is, my rectangular house is 30 feet by 40 feet. My goat Cassidy is outside on a 20-foot long leash that is connected to a corner of my house. What is the area of the region in which Cassidy can roam? So I've already drawn here a circle with the circle drawing tool on OneNote. And since it's on a 20-foot leash and it doesn't really matter what corner of the house it's on, so this 20. So this, if you can imagine this, what is the area of the region in which Cassidy can roam? If Cassidy goes this way, she can't go inside the house because, well, there's a wall, and unless Cassidy can morph through a wall and she's a super goat, then she probably can't make it into the house unless she knows how to open a door, but that's on a totally irrelevant tangent. But her 20 long leash has the corner of the house as its center of the circle. Therefore, its leash area will basically revolve around the circle onto each side. However, like I said, since Cassidy can't go into the house, she only has 3/4 of her circle to go into because the corner of the house blocks her from going in. Therefore, the formula for the amount of area in which Cassidy can roam is 3/4 times pi. And our r here is 20, so 20 squared, which is then equivalent to 3/4 times pi 400. Combine the 400 and the 3/4, in which you'll get 300 pi. Moving on to problem number 2, this one is slightly more complicated. If I lengthen Cassidy's leash to 50 feet, then what is the area of the region in which Cassidy can roam? So let's assume that we're still on the same corner, because it doesn't really matter what corner she's on. So this is now a 50 feet long leash. And since the now the length of the leash is longer than both sides of the house, this means that she is no longer confined to just a circular area. This means that Cassidy, since she's assumably still can't get into the house, unless she got struck by magic lightning or something, when she goes off this side, and if she still has the corner of the house as the center of the circle. But if she goes off to the left over the 40-foot long area, this means that she still has a 10-foot long leash left behind that she still has not basically quote-unquote used yet. This 10-foot leash can still draw a little circle around here, as this corner of the house is now basically her new quote-unquote circle heart, as she is curving around this little area. Therefore, since this area is now the circle heart, and this bit, if she goes back this way, is covered in a circular motion, so since this is 30, so this is 20, looking something like this, that means that this area only has this bit, using the 10 as the radius to roam. And it's the same for the 20-foot side, as it also has this bit, so I'm just going to highlight it. It has this bit already covered if she goes the other way. So this means that if she goes continuing, she only has this 1/4 of a circle, using this corner of the house as her circle heart, and it has a radius of 20. Therefore, if we're trying to calculate what the total area of the region it is, it would basically be equivalent to, since this is 1/4 of a circle, 1/4 of a circle, this is 3/4 of a circle. This means that we'll get 1/4 times pi 10 squared plus 1/4 times pi 20 squared plus 3/4 of pi 50 squared. So now if we solve for this, we're going to get, since this is 100, so 25 pi plus this is 400, so 100 pi. And since this is 2500, so 3/4 times 2500, since the 2500 is basically equivalent to 100 times 25, and 100 divided by 4 is 25, this is basically equivalent to 25 times 25, then times 3. So since 25 times 25 is 625, we therefore have 625 times 3. I'm going to expand this into one more step and combine the two pi's. So 125 pi plus So 600 times 3, which is equivalent to 1800, 25 times 3, which is equivalent to 75. So 1875 pi. Add them together and we get 2000 pi. So Cassidy now has a very large area to roam. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!